Lab Guy here. We are now testing the PhiloCam 1-inch vivisector camera. Construction is complete of the test article, and you are looking at the raster on the oscilloscope, and we have reached the point that this tube can now image a flashlight. You can just make it out. There's not a lot of gain at this point, so I'm still working on that. I'm going to build a video amplifier with an AGC that can track this thing, because the dynamic range on the output is very big. So there you are. That is, wow, that's working better than it has. Earlier today I thought I burned out the tube, but I guess I adjusted it out of range in my excitement while I was working on it, and then ended up with no signal. That was quite distressing. Let's take a closer look at the test setup. Since part 3, there have been a lot of upgrades on this project. In the last report, the high voltage power supply was shorted out. Those feed-through capacitors that I used apparently had an upper voltage limit of 600 volts. And every one of the feed-throughs that was over 600 volts, including the 600 volt one, had all shorted out and knocked out the voltage divider string inside the box. So only recently did I get back to this project, and I solved the problem by placing all of the feed-throughs on a piece of phenolic board that is not connected to the back panel, and it is now operational. The PhiloCam consists of a 1-inch vivisector tube made by IT&T in approximately 1978. It is housed in a standard 1-inch Vidicon tube deflection yoke and focus coil. It has the lens at the front. Almost all connections go through the back. The highest voltage is at the front, connected to the photocathode. The output pin is the most positive pin on the tube, and it's the anode. This power supply operates this tube exactly as you would operate a photo multiplier tube. It has the additional section that is capable of scanning its photosensitive surface. Scanning is driven by the X and Y amplifier, which gets its signals from 2 WaveTech audio generators for generating triangle waves for my scanning. The amplifier then kicks up the signal generator voltages and currents, specifically the currents, to drive the 2 deflection coils. Down here is a small current regulator board that sets a constant current in the focus coil of 60 milliamps. It's not really a focus coil per se, it's a collimator. But that's not necessarily important right now. What is important is that this project and the previous image dissector project are the only homemade image dissector camera projects. Correct me if I'm wrong. So, as you saw in the beginning of this video, this camera is now capable of producing the blurry image. From this point forward, I will get the optics set correctly. I think they're pretty close. I suspect I don't have enough current in my focus coil yet. So with that, I declare that the PhiloCam image dissector camera project at Lab Guy's World is 100% successful tonight. Lab guy out.